Welcome, boys, once again for the chapter gravitation. We have started numericals, the problems related to gravitation, and we during last previous numericals, what we have done, we have basically applied the techniques of the Newton's law of gravitation to calculate some of the problems which were asked. Now, during this problem, the value of g due to find the value of g due to Earth, a geostationary satellite. The radius of geostationary satellite is this one, and you are asked to calculate the value of g. So here it is. This is the formula used to calculate value of g. It is basically square of the distance of the radius. That is the radius of stationary. It was kilometer. Then we have calculated in meter, multiplying it 1000. So here it is. It is basically 4.87 into 10 raised to the power 7 whole square. So this is the value of the g, and you need the mass of that. It is 6 multiplied 10 raised to the power 24. After putting all values, you are getting the value of g due to Earth and geostationary satellite. So this is the answer to calculate. What you need the value of g, you need the mass of the Earth, you need the radius of the planet. So after putting the values, you have calculated. So another problem is the value of g is here. You are given value of g, that is 4 meter per second square at a distance of 10,000 kilometers from the center of the Earth. Find the mass of the Earth. You are asked to calculate the mass. So here it is. The total distance is 10 raised to the power 7 meter after putting the values. Simplification. Value of g is this one. So this is the formula to calculate value of g. G is equal to gme, mass of Earth, divided by radius of the Earth. All values are given. So what was the distance from the mass center of the Earth? That distance, put the values of that distance here, 10 raised to the power 7, and take the square of that value, 10 raised to the power 7 whole square. So this is the formula gr square divided by g. If the distance from the Earth surface is given, you will put the value of g, you will put the value of capital G, gravitational constant, and then you will be able to calculate the mass of the Earth. So this is the same type of the formula which we have already applied. But you need to understand the value of g formula. Why? Because here the value of g is given, radius is also given, g is constant. So if you are asked to calculate the mass of Earth, this will be your formula to calculate mass of Earth. So here it is another problem where at what altitude the value of g would become 1/4 to that of the Earth's surface. It's very simple. It means at a height where the value of g becomes 1/4 means normally the Earth's surface it is 10. What will be at 1/4? That is 2.5 meter per second square. And you will put the all values here, and then you will be getting altitude. So altitude is r plus h whole square, that is gm m divided by g. So this is the formula. You have simplified it, you have taken it, the value of g at altitude at h. So this was the formula to calculate value of g at altitude at height h above the surface of the Earth. So after putting the values, you are calculating, after putting all values, you are calculating value of g at a certain height. If you are asked at what height, 1/4, 1/9. So it is, if it is 1/4, you will put here 1/4 value of g. This one is at surface. So whenever you move up to 1/4, this will be, if you are 1/9, it will be 1/9. If it is 1/15, 15, then 1/15. Then we will calculate the value of g at. Then what you are asked? Altitude. So this is the formula to calculate the value of g at a certain altitude. You will put the values and simply you will get it done. So with this, I thank you very much for today's class. Hope you will have understood today's topic. Thank you very much.